Right, so for today's lesson, we're going to talk about different properties of numbers. So the first property that we talk about is the commutative property. And the commutative property basically just means that however you add or multiply numbers, the order won't make a difference in your result. So commutative right here, it's over addition and multiplication. And then the way you're going to remember is you're going to change the order and answer remains the same. So if I wanted to do something like 3 plus 8, that answer is going to be the same as if I were to change the order and do 8 plus 3. If I did something like 5 times 4, it would give me the same answer as 4 times 5. So commutative property means to change order. The associative property is also over addition and multiplication. And associative property means you're going to have the same order, but your grouping symbols are going to change. So this is going to be same order. That's why I circled the SO. Same order of numbers, but grouping symbols or but parentheses change. For example, if I wanted to do something like 1 plus 2 plus 3, and I put my parentheses around the 1 and the 2, that's going to give me the same answer as 1 plus 2 plus 3, but the parentheses around the 2 and the 3. So on the first side, the left-hand side, 1 plus 2 is 3, 3 plus 3 is 6. On the right-hand side, 2 plus 3 is 5, and 5 plus 1 is 6. It works the same way with multiplication. I could do 1 times 2 times 3, and that would give me the same exact answer as 1 times 2 times 3. The distributive property, I think you guys know that already. That's when you kind of have, you multiply the outside number to everything on the inside. So for example, if you had something like 5x plus 2, when you distribute, you get 5x plus 10. So multiply outside value inside the parentheses. Then we start talking about identity elements. And if you think about your identity, you are who you are. You're not going to change who you are. Maybe it's Halloween coming up, and if you put on a costume, under that costume, you still are who you are. So your identity is you basically are going to always stay who you are. You always stay who you are. So the additive identity is going to be 0, right? Because I can add 0 to any number and I'll never change that original number. 5 stays as 5 anytime I add a 0 to it. The multiplicative identity is going to be the number 1, because anytime you multiply a number by 1, the answer always remains itself. So it's who you stay yourself. Then we start talking about inverses. We've got multiplicative inverses and additive inverses. And inverses are ways to get you back to your identity property. So inverses, when you actually do the work for it, is your answer must be the identity element. In other words, for additive inverse, you got to find two numbers that add to give you a 0. So you're basically going to be adding opposites. So if I had 5 plus -5, that answer is 0. Well, 0 happens to be the identity element for addition. That's why 5 plus -5 opposites are additive inverses of one another. Multiplicative inverses, you need to get to the identity. You got to find two things that are going to multiply to give you a 1. Well, let's talk about a fraction in this case. Let's say I had 2/3. Well, 2/3 multiplied by 3/2, its reciprocal, equals 1. So when you multiply by a number's reciprocal, that's what gets you back to the multiplicative identity. So reciprocals are multiplicative inverses of one another, and opposites are additive inverses of one another. The last thing that we have is something called closure. And it's always a little bit kind of tricky to explain, but it shouldn't be so difficult. A set is closed with respect to an operation if the result of performing that operation on members of the set result in the numbers of that set. Basically what it's saying to you is if I were to think about whole numbers, it's going to be more of an example. Okay, so if I think about whole numbers the set from 0 up to positive infinity. Well, if I wanted to do addition with some whole numbers, let me take some whole numbers here. Let's take like 3 plus 7, right? Those are both whole numbers. If I add 3 plus 7, I get 10. And because 10 is a whole number, it's a part of the set I started out with, then addition is closed for whole numbers. If I think about multiplication, and if I multiply 3 times 7, my result is 21. Well, 21 is a whole number. So whole numbers are closed with respect to multiplication. When I think about division, if I do 3 divided by 7, I'm going to get some decimal answer. I'm not really sure what that decimal is, except I know that 3 divided by 7 gives me a decimal. Decimal numbers are not whole numbers, so whole numbers are not closed with respect to division. Even though I can find some whole numbers that divide to give me a whole number, like 10 divided by 2 is 5. 5 is a whole number, but 5 divided by 10 is 1/2, and that's not a whole number. And then subtraction, if I do 3 take away 7, I get -4. Well, -4 is not a whole number. So when I'm talking about subtraction in respect to the set of whole numbers, it is not closed. So bottom line is whatever operation you do with the set of numbers they give you, in order to be closed, your answer must be a member of that original set. Here are a couple of practice problems. So determine which property each equation illustrates. Well, if I'm going to add something by 0 and get itself, this is going to be my additive identity. If I take a look where I've got parentheses and I'm doing addition, I've got the order of the same, ABC, ABC, just my parentheses changed. This is the associative. If I take a look at the next one where it's addition and I've changed my order, A plus B equals B plus A, that's my commutative. And if I take a look here where I've got parentheses in the beginning, but then the parentheses go away, that's my distributive. Additive inverse. I need to get back to a 0. So what's the opposite of 2/3? Well, -2/3. Which property is illustrated by ax plus ay equals a times the parenthesis of x plus y? It happens to be written differently in the sense that you tend to see the parentheses first, but it still was the distributive property that was used. The operation element of like that symbol is determined by the following table. What's a little bit different about this is you've got to stay who you are because we're dealing with the identity element. So if I take a look at this particular piece, highlighter, okay, so if I'm looking for ABC, that's the exact same way underneath its table. I see that that's my ABC. And this happens to be, the element is A. And if I happen to look going down, ABC, I happen to see right here, ABC. So the way to keep the heading and like, I guess the column and the row, if you will, the exact same as it starts out as, the identity element is going to be A, because that's the only way when I look across the A or down the A that I've got the table the exact same as the headers on either side. And this next one, under which operation is the set of odd integers closed? Well, let's think about some odd integers here. If I take odd integers and I start off with, let's say, 3 and 5. If I do 3 plus 5, I get 8. If I do 3 minus 5, that's an integer by the way, I get -2. If I do, what else? If I do 3 times 5, I get 15. Oh, this is why I'm questioning myself for a second. Is a set of odd integers closed? Well, 3 plus 5 is 8. 8 is not odd. So 8 is even. So it's not closed under addition. Here we go. 3 minus 5 is negative 2. And negative 2 is not an odd integer. So we're not closed under subtraction. 3 times 5 is 15, so I'm going to think about this might be a possibility. And that's if I do 3 divided by 5, I get a decimal, which is clearly not an odd integer. So really, when it comes down to it, we're closed under multiplication for odd integers. Okay, and that's it. So good luck on the homework.